Hey everyone, Aditya here. Welcome to my channel. So from today we're going to do some comprehensive coding. I'm preparing for the interview. So for that I'm preparing the coding questions. So I will solve those questions in these sessions so that I can get benefited along with you guys also know what are the questions uh, these companies will ask, like product-based companies will ask, and how to solve those questions. So first, I'm going to open the question. The first question I got is the remove duplicates from the sorted array. This question is a very popular question, so we need to remove duplicates from a sorted array. So we'll see what was the question says. So given an integer array, so we have an integer array nums sorted in non-decreasing order. Remove the duplicates in place such that each unique element appears only once, and the relative order of the elements should be kept the same in, so return the number of unique elements in nums. So we'll go to the question again. So we have given an integer array, so we know that what is the input, so an array, and which is a sorted, so this thing we need to note, which is a sorted one. And now what here it is saying, it is a non-decreasing order. What is non-decreasing order? We had about increasing order. We know the previous element could be greater than the current element. That is the increasing order. What is non-decreasing order? Non-decreasing order is nothing but the previous element could be the equal or greater than the current element. That is the thing about non-decreasing. And now what he is asking, we need to remove the duplicates. So that will be an easy task when we can create any other data structures like map, set, or not. But here he had a trick like use an in place. So here you have to use an in place technique to remove those unique elements from your sorted array. Okay, so in place means you have to work on the same array. But the thing is, even though you remove duplicates from the array size remains the same because array size is not dynamic one, it's a static one. Okay, that thing you have to keep in mind. And also he mentioned that relative ordering of the element should be kept. So after removing your duplicates from your array, you have to keep the relative order. So that is one more thing we need to keep in mind. Okay, and finally what we have to write is number of unique elements in nums. So it's simple. So we need to calculate the count of unique elements and return back to the uh, return back, but internally we need to change the given nums array in such a way that all the unique elements will come in the same order and all the duplicates will remove there, and we don't keep any duplicates, right? We are not just simply returning number, we have to change the underlying array also. We'll see. We have few considerations he mentioned. Consider the number of unique elements nums to be k. Let me get accepted. You need to be to the following. So what we have to do? Change the array num such that first k elements of the nums contain the unique elements in order they were present in the nums initially. So simple. So if you have an array and you want if you encounter any duplicates, remove them and make your unique elements to come forward and replace that place where you removed the duplicate one. Like that, you calculate first distinct and first unique elements and return the length of those elements. Okay. So if you see here, we have few examples. So if you take this one, and here the duplicate is 1, so after removing 1 the array should look like this 1 comma 2, but in array the removal is nothing, is not like an other data structures, right? The size won't be changed, so the size should be same. But why? How to determine the first the array which with the unique, right? These two values, so we have to send the length of the array up to these two unique values, then only um, we can say we arrived an solution with unique values. Okay, so this is another example. We have 0, 0, 1, 1, 1, 2, 2, 2, 3, 3, 4. So from this you will get 5 unique values and remaining has been removed, but the placeholders for those values should be keep in the array. But the thing is we can remove them by overriding with unique values in the same order which they appear and return only the first unique elements count, so that if we iterate over that count we will get all the unique elements in the array, and remaining thing anyway we are going to ignore and the question is going to ignore. So we have few constraints also. Okay, now let's try to solve this problem. So I'm opening STS. So here I have nums, which is a non-decreasing sorted array as we mentioned. 1, 2, 2, 3, 3, 4, 4, 4. So finally we have to return how many elements from this we can easily array, right? Only unique values. So I would say 1, comma, 2, comma, 3, comma, 4. So I am preserving the relating order and remaining anything. So we don't consider about remaining whatever the values is. The length should be 4. So we need to return 4 and we need to internally change our array to like this. So how can we do that? So I will show you. So here in the dedupe in place, right? We have to use in place strategy. First thing what we are going to check, we're going to calculate the given length of the array. Okay, so I'm taking a variable n and calculating the length of the nums. So nums dot length. So it will give the length of the array. So the first constant itself, if the length is equal to 0, that means there is no elements in the array, then there will be no unique elements, right? We're returning 0. Otherwise, if we have unique elements, we're going to follow two pointers array approach. So what was this? So for two-point array approach, first thing we will take an insert index where we insert unique values. So we will start from 1. Since the first element in an array always guaranteed to be unique, right? You don't need to overwrite here. But from the second element, you have to overwrite. So that's why we will start insert index from 1 and also we will iterate over the array. And the iterator also starts from the 1 since the first element guaranteed to be unique. So I less than length and I plus plus. One is insert index we will increment based on a check. So that check is we will check whether in the nums array the previous element, that is I minus 1, is not equal to the current element nums of 1. So if these both are not equal, right, that means those two are unique values. Since this is sorted array, we are ensuring that this, when we are comparing current and previous values, we will definitely know what is duplicate. So easily we can remove. That was the advantage of this sorted array. So now I am checking here and I find out a unique value. So what will I do? I will insert that unique value in the insert index. And I will increment insert index by 1. And similarly, we can do all the processing, and once completed, we will finally return this insert index. And anyway, we are doing some operations on the nums, like we are inserting unique values in this insert index, and we are changing only nums, right? So the nums array only changes, so that we will get what the desired input we're expecting. So we're expecting 1, 2, 3, 4. So once we receive this unique length, we'll go through the unique length through the nums of and we'll find it. So I'm selecting and right click, run as Java application, and boom, you can able to see it 1, 2, 3, 4. So I got all the unique elements uh, in a relative order without changing the order. So we can use this two-pointer approach to do such kind of things. One is tracking the insert index and the other is tracking the traversing through the array.